This to me was more of a like, hey man, we're normal people like you guys are.
I'm not up. I'm drunk. And then when I'm done with that, I put Vaseline actually around the edges. Just ordered somebody. That was him. Welcome everyone to Top's Daily Grind. This is episode number 140, and we are here with Teyen. Is that
Yes.
am I pronouncing that right? Okay. So we're here with Teyen, and he is from Australia.
Yeah, raised in the UK, born in Australia.
Nice.
And over here from Australia.
Awesome. Okay, so tell us what you do.
I am an Astro Nuclear Engineer.
Jeez.
Yes.
So it's more simple than it sounds.
An Astro Nuclear Engineer. That's like rocket science, dude.
But with nuclear stuff as
Yeah.
well. It's like nuclear rocket science.
Jeez.
Yes.
Mostly.
We've graduated to a whole new level.
Yeah,
today.
I don't know what to ask.
We everybody said bring an expert, and we brought an expert. We just don't have a topic yet.
So we don't have-
Like an expert in who
okay,
knows
so
what.
somebody, what would a good question be? You have to start with the basics.
Oh yes, this is a good starting point.
Okay, so somebody has never heard this term before.
Yes.
Well, how would you explain it to them?
So-
And if you could move your cup that way so we can see you.
Oh, that's the worst idea. It's nuclear technology in space. So currently there are two things that we have, and they're both based on the same sort of thing. So you have a lump of plutonium oxide that stays hot because it decays radioactively, and so that when it gives off its alpha particle, it rattles around in the material, and so you just have basically a hot rock effectively, and then you take the heat from that and you use that to generate power. So the only nuclear part of it is the fact that it's radioactive. So that's what we have at the moment. And what they're hoping eventually to have, and have been hoping since about the 50s, they built these things in the 50s, is a thing called a nuclear thermal rocket. So instead of burning your fuel in oxygen and then using the energy that you get in the combustion gases to propel yourself, you use hydrogen or something else, and you heat it up in a nuclear reactor, and that's where your heat comes from.
Okay.
So it's to say we built them in the 50s. You built them in the 50s in the US, and since then, a lot of it's on paper. So now with the computers that we have, we can run endless simulations of different configurations and different propellants and different types of fuel and all this sort of stuff. So it's this is what we do. Mostly we simulate things, and if we're very, very lucky, you could get a job at Los Alamos or somewhere where they make the pellets for the hot batteries. There's one on the rover that's on Mars at the moment that has one. In fact, two of them.
Wow.
It's a little thing. That
How dangerous is it? Like what you do?
I guess you could have like a computer monitor fall on you.
That's it.
Something like
Ouch.
that. Yeah, that's they tend not to let you near the radioactive stuff. As I don't know whether it's because we're too valuable or whether it's just that we'd probably break something.
Oh.
So
People, when they say using nuclear for energy, a lot of people are scared because of the word nuclear.
yes.
Is that do they have a reason to be scared, or are they completely just ignorant to what it actually is?
There's always two opposing sides, and so there are the people who are terrified of it, and a lot of it's misunderstanding. But there are also the people who are completely for it, pro. It's the best thing we could possibly do, and they sort of don't take into account the fact that the waste is building up.
Yeah.
In the civilian power plants in the US, they generally tend to have a concrete pad, and so they'll take the fuel when it's spent, which is more where the fuel goes in, it's effectively non-radioactive. There's very, very little radioactivity in the uranium when you put it in. But then after you've finished burning it, when you've done all the fission, it ends up quite hot, is the term. So fairly horribly radioactive. And at that point, if you're processing that kind of stuff, you have to be behind lead glass that's like as thick as this table. You don't want to be anywhere near it.
Okay.
And so once it's done, it becomes a problem. And the main issue is knowing where we're going to put it, which in the ideal place to put it is way, way, way underground in a salt mine, because the salt it moves, basically. So if you have hard rock and you have an earthquake or something, it shifts and you'll get cracks. And if there's water that infiltrates, you can wash some of the fission products and stuff out if you haven't encapsulated them properly. And encapsulation is a big thing. You tend to put it in glass. a borosilicate glass. The boron absorbs a certain type of the radiation. But the main issue is not knowing where to put the waste. The waste itself is not pleasant stuff.
That's the stuff that breaks your cells and messes you up and gives you cancer and all that.
Yeah, will destroy your DNA. But it's there's, as far as the fear goes, it's kind of not helped by the approach that the regulatory people take at times. So there's when you're looking at the amount of radiation you can, the dose that you can take, it's assumed the model that they use is called linear no threshold. So any amount of radiation is bad for you.
Yeah.
That said, there's radiation in the background all the time. So airline pilots also will, because they're further up in the atmosphere and there's radiation from space all the time, they end up with a higher dose than people who just live on the ground. Mm-hmm. Also, if you live on granite or I think basalt as well, there's more, trace uranium in that, so more radon and so forth that you'll get from that than if you live on a clay substrate, so like 4 or 5 times the background dose. But all this to say, background doses, you tend to look at in terms of like the number of chest x-rays that you can have. Mm-hmm. So they will limit the number of x-rays that you can have over the course of the year. But it's comparatively high. So when people think immediately, as soon as you go near anything radioactive, then everyone on the Earth would be dead. And there's also a phenomenon known as hormesis, whereby if you're exposed to a low level of radiation continuously, your cells, the DNA will repair itself.
Almost like the immune system gets stronger when it comes
with
to
exposure.
Exposure.
Yeah. Okay. Exactly. But it's not a model that's commonly used. Preferred. I mean, health and safety. We all know health and safety, and they would prefer to take a minimal risk approach. Mm-hmm. So if they were to tell everyone that if it were to be accepted that this is a thing, that exposure to small amounts of radiation is potentially good for you, then people will go crazy as well. Yeah. And they would assume, like, well, I've had a small amount, what if I have a little bit more?
Yeah, they'd go for x-rays for no reason.
Exactly.
Is that proven, though? Or is that still, like, a hypothesis? Or
I guess I would say it's probably halfway. So I can't remember where it is, there's a place in the world that has a higher regular background dose just from the rocks and from the atmosphere and so forth, than anywhere else in the world, and these people have less incidence of cancer and so forth, like radiation-related illnesses, than elsewhere in the world. But there's statistics is a big thing.
So it's like backwards almost.
Yeah,
from what you would expect just from common knowledge about it.
Yeah, and if you look at the exclusion zone around Chernobyl as well, you would, from the horror stories and so forth, you would expect that everything died the minute the accident happened and nothing's alive there. They set all these cameras up and so forth, and there's foxes and wolves and rabbits just all running around, and so it seems that they've kind of, over a course of time, the background levels dropped over a course of time, but things have moved back in, and they don't seem to be suffering the horrible mutations and so forth that you might expect.
Is there still like the ground zero area, is that still pretty much just completely dead, or is it are things starting to grow and kind of live there again?
Well, it depends on. Well, there are things living inside the concrete sarcophagus that they put over the top of the reactor. They're fungi.
Okay.
But there seem to be certain types of fungi that will use the gamma radiation that's coming off all the fission products and the spent fuel and so forth that's left in there, and that they're thriving on it. So it depends on, say, forms of life. I think the more complicated the life form is, the more likely the DNA is to be damaged. And so if you have something simple like a fungus or an algae or something like that, then things will adapt anywhere in the universe, I guess. Any conditions you can imagine, they tend to find life in. So
the fungus that's living there, is it using that radiation? Like, is it reducing it?
As I guess,
or is it just kind of like dealing with it?
I think it's using it as an energy source. It's called a radiotrophic fungus, and it seems. I think it seems to be using the gamma radiation in a similar way that plants use light, I guess.
Okay.
Or not being a botanist or an ecologist or anything like this.
Oh yeah, we're not a lot of things, but we make shit up.
Don't worry, we're just gonna nod and pretend like we know.
Yes, it seems to be. It's using some of the radiation as an energy source. It's basically just extremely high energy light.
So gamma is the deadly part,
all kinds.
Or there's more than.
It's so you have gamma radiation, which is high energy photons, and you also have neutrons, which are given off. You'll find a lot of neutrons outside a nuclear reactor. So you have a uranium nucleus. You chuck a neutron at it, it will then fission in a certain number of cases, and what you have left over, sometimes that will have too many neutrons in it, and so the neutrons will kind of boil off. And also that splitting will give rise to a whole bunch of neutrons as well, some of which will escape the reactor. So gamma and neutron are, I guess they're bad because they're neutral. They're not charged, and so neutrons will go straight through a thing, and then if they happen to be at the end of their, I guess it's a bad way of putting it, 15-minute lifetime, but it's half-life, so if you have like 15 of them, 7.5 will be gone within a certain length of time, and then in the same length of time, like 3 and a bit will be gone, and then...
Oh, that's how that works. I always thought it was like if it's a 15-minute half-life, that means that 30 minutes it's full life.
No, so it's half and half and half. It drops exponentially.
Oh,
so.
kind of like Bitcoin.
Yeah, pretty less precipitously than Bitcoin. But yeah, so things that are neutral, neutrons will go into a thing and then they will split apart into protons and electrons, which are charged, and that's what does the damage to the DNA. So the reason the neutrons in particular are dangerous is because they will go far through a thing and then decay into charged particles. Gamma rays, they're photons, so the more energetic they are, the further they go through stuff, so the harder it is to stop things from getting anywhere. And then you have charged particle radiation, which are high-speed electrons, and alpha particles, which are helium nuclei. And because they're charged, they do the damage as soon as they hit the thing. Alpha particles, however, are stopped by the skin. A bit of paper, something like that is enough for them to bounce off because they're kind of heavy. And so they're only really a hazard if you breathe them in. So radon, when you breathe the radon in and then it decays, it emits an alpha particle, and that's a high-speed charged particle which will ruin the inside of your lungs. But as long as it's outside, it's not touching the squamous tissue, as they say, then it will... Not to say that it's wise to go and just sort of, paint yourself with radium or whatever, and just... The Victorians learned that. They thought it was good for them, and then they all died of cancer, so... It's, not wise to eat radioactive materials, regardless of what it is, but... Yeah, different mechanisms.
Okay.
Different
You heard that?
Yeah, I'm
Okay, no eating like lead paint stuff.
Yeah,
like
John,
that.
you really got to knock that off.
Yeah.
But I had a question. So you said that you were born in Australia, raised in the UK, and then back to Australia.
Yep.
What made you get a job here in the US? Being what you are now, do we have something that other countries don't have?
That's a good question.
Yeah.
As in like science-wise or engineering-wise, or you know what I mean?
Maybe just opportunities.
Yeah, very much. You have I get in trouble with the rest of the world for saying this, but you have a space program that's a way more ambitious space program than anywhere else.
Okay.
So these nuclear batteries, that are the other thing that we work on, are in Europe. They're kind of thinking maybe that they might use some of the stuff that their plutonium stockpile has decayed into as this kind of fuel, but it's nowhere as good as the fuel that's specifically made in the US for these things. So it's way more ambitious, way further out.
Do you think countries see that we're just another country just dumping a lot of money into something that going to the moon or whatever it is going into space? Or why are other countries doing it? Because it's costly? Because, like you said, there's no ambition?
Yeah, I feel like there's less ambition. That if you want to do a thing in the US, it's like you can ask somebody, why are you doing this? And they will turn around and say, well, why not? Because we can.
That's enough.
That's a U.S.
Yeah.
thing.
That's enough of an answer
that's enough of an
to
answer.
get funded and...
Yep.
Interesting. Yeah, because I always thought that perspective, like, why do we do, like you said, why do we do things? I'm sure we have bigger problems that we should be solving instead of, like, and I'm guessing that's maybe what other countries do, or like you said, maybe it's just there's more logical thinking behind things besides saying.
I feel like red tape and health and safety is also a thing elsewhere.
Yeah.
It's just more difficult to get these things. Once you've done a thing once, then you know what the risks are.
Right.
Whereas if you've never done the thing, then how do you know what the risks are?
Exactly.
And if it's excessively risky, a lot of other places are very, very risk averse, I think. And then there's places like, Canada's close, so they make some contributions to the space program. Australia is just far away from anywhere. So, kind of other places making inroads into it, I guess, and building rockets. And there's Rocket Lab, which I think they're a US company run by a New Zealander or something like that. So, There's little bits and pieces going on elsewhere, but say here, it's no one else has been to the moon.
Right.
I had people tell me, or people ask me, like, why are you going to America? It's full of Americans. Before I went to the US.
I know, we're so terrible.
We're Mexican over here.
It's
That's worse.
Don't let me get started on them.
but it's
I'm just kidding, Mexicans out there, people,
ambition is
friends, family.
doing a thing just because you can. I think that's
And then I guess the second part of whatever I was thinking in my head, and why the lab that you're working at now is compared to other labs, because I'm guessing they're all over the U.S. Is it like the Princeton or the Yales?
Damn, John, with the good questions today.
there's not a lot.
bad.
Yeah, it's a good one.
Not a lot of places that deal with specifically with space nuclear stuff. Just because it's such a tiny thing, and say because all we have, at the moment all we have are these batteries with the hot radioactive rocks and heater units as well. So there's a limited number of places that deal with that kind of stuff, and for Idaho, the reason the Idaho National Lab is here in the first place is because originally it was in the middle of nowhere.
Right.
They were just looking for somewhere where they could build all manner of different models and types of reactor and test them out, where basically no one was going to complain.
Yeah, and we all moved around here.
Well, I mean, it's still
Pretty out.
there's not much out there at the moment.
Because for us, like, we live here, so like the lab for me is like, oh yeah, you're trying to make good money, just go to the lab. Really, that's in reality.
Most people don't know what
doesn't
even
even
goes on
don't
there.
know- yeah, exactly.
It
That's
doesn't
what
even
I'm
matter
saying.
what the job is. Like
Yeah.
a janitor there makes decent money.
Yeah, that's what I'm saying. Like for us, it's just like if you're not really into it, or you don't have someone that works there, maybe, or
You're the fourth person that's been on our podcast that works there, right?
Well, I guess
Yeah, I think so.
Yeah.
I guess I can't say that I work at the Idaho National Lab. So what with the Center for Advanced Energy Studies down in town is I think it's owned by, like, the building is owned by the Idaho National Lab, but it's a consortium between the Idaho State University, Boise State, and the University of
Oh,
Idaho.
okay, it's the one that's by where my wife works,
Yeah.
I think.
Yeah.
but
Okay.
there's a lot of like, even I guess you could say like outside contractors. Like a lot of my friends work not for the lab, but they work for companies that work at the lab.
Yeah.
You know what I mean? And but same like I go back to my thing, like same concept for us that don't really have something to do with it. Like, oh yeah, he just works at the lab, or oh yeah.
So you don't get like transferred from here to say Los Alamos or
I mean,
like
I guess you can. There's a lot of movement around. It's said that there are employees of the Idaho National Lab in like 40 of the 50 states or something, just scattered all around because people are working remotely and they're working on different contracts, and I guess the facilities are elsewhere that aren't here. But
I think there is quite a bit of that, especially in the last. It's like since COVID, it's probably even more prevalent.
Yeah.
Are there ever like projects where you only get like a certain amount of knowledge that you work on and that are like how do you say it?
Compartmentalized.
Compartmentalized. I can't speak, but
I guess one of the things that we have at the CSNR is because there are. So I'm a foreign national, evidently, and we have a lot of foreign nationals who come. Usually, it's about like a third to half of the people who are on the fellowship at any given time we source from universities around the country. So they'll have either a close to a majority or almost a slight majority of foreign nationals. So if we get set a particular project, then the way export control works and international traffic in arms regulations work is it's some of the things that you're not allowed to know as a foreign national are just ridiculous.
oh, okay.
So there'll be like a specific number that characterizes it, like the length of a thing or the exact diameter of a thing or the exact temperature or the exact alloy that you're not supposed to know. And
Does it affect your ability to do your job at all?
no, so you build the model and you use whatever numbers you're given,
Oh, okay.
which are usually like a little bit outside, but it's once you've built the model, all they have to do is go in and tweak the
And
numbers.
fix the numbers.
Put the right ones in. And
But is that
hopefully
just because
it
you're an
still
outside
works.
national? But if I had the exact same job as you, I would get the
You'd be allowed to, but if you were working on the same fellowship,
You'd probably
because
get the
there are
same-
others-
right. Okay.
If you had
so-
the same job as him, the world would be a very different place. It's just
Okay.
I think it would be more. It would be more interesting.
it probably would
We're
be.
gonna get
that's
that
true.
sucker up in the air faster than you think.
straight.
So you know how there's a lot of stuff. So everybody's like, what does NASA do anyway? But there's a lot of tools. There's a lot of stuff that's made by NASA that we use every day. Is there stuff like that we use every day that you guys have worked on, or not really?
Not that I can think of from the Center for Space Nuclear Research, but there'll be things that have come out of the lab that have ended up just everywhere that you don't realize. I can't think of any at the moment.
So there's a dude that was a NASA engineer that either improved or invented the tankless water heaters that most people use today.
Oh, okay.
That guy, he was looking for a way to heat water on the space station, and the things that existed at the time sucked. Like, they weren't very good. So the ones that you get now, the tankless water heaters you get now, they're pretty legit.
Yeah, and they're small.
Like, you actually get hot water out of them. That came from a NASA engineer. So
Those
there's
are
a lot of
actually-
offshoot technologies
You
like
get
that.
hotter water in those than the other ones because you.
Yeah, I think
'cause
now you do.
The warnings are that you can burn yourself pretty bad if you don't know how to adjust it.
Yeah, I remember back in the day using some that like barely even touched the water. Like, it barely warmed it at all. But this guy figured out how to do it and make it hot. So that's one thing that was like an offshoot from a NASA technology.
I think the cordless drill, that might have been.
Oh, I
them
think
as
you're right.
well.
I think so.
There'll be all kinds of little things like battery technology and so forth that was kind of shitty at one point and then needed to be better, and so it became better, and then eventually it got. I think for every dollar that this is my yay NASA speech and why we should have it. For every dollar that's spent on given to NASA to do stuff, I think they calculated they get like $6 back or something just from like the wider economy when they adopt the various technologies and so forth that are developed. So
Yeah, that's a pretty good reason to keep doing that.
Yeah.
You know, that makes a lot of
We're
sense.
all
We should open up more NASA's.
We're all
absolutely.
NASA fans here.
Yeah,
Well,
yeah,
well,
definitely.
Craig and I don't know about John.
So
I don't think John
you're-
cares.
I'm part of all NASA, especially with the $6.
Yeah. So your main focus is on the actual like rocket type technology with nuclear, or is it on the battery part?
it depends on the year.
Okay.
So last year and the year before and the year before, we did a bunch of battery stuff. This year, we've done more rocket stuff. So, I mean, we started off, I guess the first year we did a bunch of rocket stuff and not so much battery stuff. It depends on who wants what work doing.
Gotcha.
So I get a contract in and then we work on, we kind of do what we're told, more or less.
So did you have a part in the battery that's on that rover on Mars?
Sadly,
in
no.
some of that development?
It was already there by the
Oh,
time we
okay.
got to it. But
Gotcha.
then there's a lot of stuff that happens if you've. What I did my PhD on was looking at how the radiation that comes off that battery interacts with the environment that it's in.
Oh, okay.
So they're sending in 2027 they'll be launching a lander to Titan, which is the moon of Saturn. And so they'll be putting another one, the third one of these things that's flown, they'll be putting on that. And there's obviously a bunch of instrumentation on there. It's going to take 7 years to get there, 6-7 years rather than 18 months. So over the whole phase of going out there, you've got a whole bunch of really sensitive radiation detectors and things that you use to figure out what's in the rocks and so forth. And you're continuously bombarding that with not only cosmic radiation that's coming in from the outside and from the sun, but also the radiations that's coming off the batteries. And so specifically I looked at what happens when the thing lands and you've got all this radiation coming off. Is it going to upset all your instrument readings? Is it going to ruin the detectors? We don't know. And the ultimate answer is the great thing about research. The ultimate answer was probably not very much, but still it was worth
It's like such a mundane answer. It's like, nah, it's probably fine.
Yeah.
Yeah, exactly.
Is that the one where they found the
liquid-
building blocks of life, basically?
Some of, yeah.
That's
Like
the one that
organic
has like the methane lakes.
Is it
and
ammonia
stuff
or
like that?
no?
Yep.
Is it methane?
Methane, ethane. Yeah, methane and ethane. And
Yeah, you have to
also
say
kind
methane.
of tars and stuff
Damn it,
like
Craig.
that.
You're fucking
Sorry,
embarrassing us.
I was born here. I say fungi and,
Yeah, what the heck?
and methane.
Strange question off of
And
what
I
you're
say
talking-
aluminum. Do you say aluminium?
I'm starting to say aluminum, but I catch myself. And so what I prefer is aluminum. Just 'cause
Nice.
that's near
Just to
the
confuse everybody. Yeah, that's
That would
perfect.
make sense.
Exactly.
Is so hypothetical here. Say you and a coworker are talking, right? You guys are talking about what you guys are doing. What percentage of what you guys are talking about do you think like somebody like Craig or me would understand?
Well, it's
Ouch. Ouch.
I included
I
myself.
would understand,
Dang,
but
that
you guys
hurts.
probably
That
wouldn't.
hurts.
So about 2%, and then what do you think?
1.5.
It's got to be a good 50% because you know how a car engine works, right?
Yeah.
So this is heat turning into useful work.
Okay.
So I mean, something like a jet engine is again heat turning into useful work. So the nuclear side of it is just this is how you're generating the heat, and the safety considerations because of the radiation. But beyond that, it's conventional engineering if you replace the heat source.
Oh, okay.
Okay.
So
Oh, that makes it sound a lot more simple.
Yeah.
I want to kind of add a little bit on to the whole coworker thing. In my line of work, if I have a question, there's an answer, and if I don't do it right, I understand why I didn't right because there's someone above me that told me you did that wrong. In your line of work, since you guys are trying to find something that you think
a good
that might
question.
work, who's above that calls the call? Makes the call to be like,
Or how
yes,
do you-
let's do it. Or how does the person that
Yes,
makes the call
go.
know that it's right?
There you go.
that's difficult.
good question.
Difficult to know. So if you're modeling something that we built nuclear rockets back in the 60s, like the Nerva rover program. And so if you build a model of something that already existed, then you can go through the data, and the ghosts of the past will tell you that you've screwed your model up. Whereas if it's something, the only thing you can do really is you go through the steps and you make sure that you've got the right materials here and you've got the right, you've set everything, you've built the model right. And at that point, you're just kind of trusting that when you do the digital equivalent of throwing spaghetti at the wall, that it's accurately modeling that.
Okay.
Ultimately, you never really know. And this is the thing, being an experimental engineer rather than a highly mathematical, you never actually know until you build the thing.
Okay.
Because reality will always surprise you. So I think they turned on the Large Hadron Collider, the thing that's in Switzerland?
Yes.
I have no idea.
Yes.
Big old particle accelerator, they've got that.
Yeah, they were gonna make it in Texas.
It's a
but
really
they
huge
didn't.
thing that throws little tiny things at each other.
Yes. You can't see.
Extremely fast. So they built this, and then they've superconducting magnets in there, and liquid helium, and all kinds of incredibly high-tech stuff. And it broke down because it was overheating, and they couldn't figure out why. So they've got these thousands of engineers and scientists just scratching their heads and looking at this and thinking, like, why is this doing this? Why is this not working? And what they found out in the end is there was a vent that went up to the surface, and there were pigeons that would be eating bread. They would take the bread and they would sit on top of the vents and chew the bread, and the crumbs would fall down the vent and clog stuff, and the whole particle accelerator would break
crazy.
down. So it's easy to get lost in. You kind of assume that there's got to be some highly technical answer to it, but it can just be that.
Have you guys ran a model that worked in the model and then in real life it didn't?
Difficult to say because the real life things that we have are the batteries and.
Oh, okay. So it's not like
properties
there's a lot of things that you guys are. Oh, okay.
Some of the things we're not allowed to know, so we could get model results and it looked fine to us, and then it goes beyond.
And you'll
that.
never know.
Yeah.
John, you can come over here. Leo's probably not going to make it up.
No, I'll go over
I
there
already-
and then
Yeah,
we'll
that was-
we're
scoot down.
switching spots.
Yeah,
And
we'll
so,
scoot down.
I want to go back to this Titan thing because that sounds freaking cool.
I'll have you jump on the next seat if you can, and that way I can take my. Yeah. Okay.
Do I get the gavel?
There you go. Yes, you can have
I am
you can
the
have total
law.
control. So this, I remember following like the whole Cassini thing and all of that. Like that was super interesting to me. So does Saturn throw off a bunch of radiation that might mess with the stuff
And
as
what's
well?
the hexagon?
The hexagon is Rossby waves. But I'll get back to that.
Oh
It's,
yes. Oh yes.
We're gonna geek out over here.
I guess you get magnetic fields, and then the sun, being a giant ball of fusing hydrogen, chucks off a lot of that hydrogen. So some of those particles get caught in the magnetic field and accelerated around, and so that can cause damage. The Earth has the same thing in the Van Allen belts where particles
Right.
get trapped, and then there's a place just over the South Atlantic where if you have a satellite that's orbiting, the best thing to do is just shut it down whilst it's going through and then turn it back on the other side, because if you have anything running, you go through the radiation and it will
Just burns it.
blow circuits and so forth.
Okay.
So yeah, that does happen at the time.
So is the atmosphere on Titan's like really, like a lot stronger than? So everything's gonna be a lot heavier, right?
It's 5 times the density.
Okay.
I think the pressure's 1.5 times, 1.4. the gravity's very, very low.
Oh, okay.
So flight is incredibly easy there. It's the only place in the solar system.
What are you looking for?
My cup.
Oh, that one. Yeah, only place in the solar system as a human being you could, in a spacesuit, because it's at minus 500 and something Fahrenheit, that you could have wings just attached to your arms and you could flap them and you could lift yourself. You could actually fly.
Dude, that's crazy.
That's so cool. Okay, so it's. I don't know why I was kind of almost imagining it like Venus, that you were going to have a hard time building something that wouldn't just
the
like
pressure?
collapse on itself.
It's the pressure's only 1.5 times Earth.
So
it's-
okay, so it's not too bad then.
So it's like being in the ocean, like, say, 10 feet, 5 feet.
1.5.
That's it?
Yeah.
Really?
I think for every 3 feet down you go. No, wait. Yeah, every 3 feet down you go, there's effectively a ton of water above you.
Oh, okay.
So 10 meters down in the ocean, it increases by 1 atmosphere. So yeah, 15 feet.
Okay, there we go.
15 feet.
I wasn't too far off. Oh, look at that.
Yeah. Okay, that's cool. So, so you are you the models when you guys run these models, you get a result, right? How many times do you run the model and get a result that's completely different? And how many times do you run the models and all the results are kind of like close? Like, is that a question that makes sense?
Yeah, you always get a spread of results because the Monte Carlo method is what it's known as. So Monte Carlo, the gambler, which is throwing spaghetti at a wall. So mostly you'll get pretty similar results, and in fact, you want slightly different results each time you run the simulations, so that you can compile them into one big. You get a distribution, statistical distribution, and the more simulations you run, the more accurate your answers are going to be.
Okay.
So the closer to the finer a point you put on the problem, basically.
Yeah, there's like that bell curve or whatever, right?
Yeah.
And that just gets smaller the more you.
Yeah, you get
the more you run it. Okay.
closer and closer. It's the number of particles. The square root of the number of particles is the error. So if you run 1,000,000, then the error is 1,000. But then 1,000 divided by 1,000,000 is 1/1,000. So that's 1 part in 1,000. Whereas if you run 10,000, your error is going to be 100. And so 100 divided by 10,000 is 1 in 100. So you run 10,000 particles, you'll get 1%. You run 1,000,000 particles, you'll get 1 in 1,000, 0.1%, and so on and so on. So
Gotcha. Okay.
Back to Saturn. And the hexagon.
Yeah. Yeah. Talk to us about this hexagon, because that is super strange.
Because we never go back to our questions.
For there to be a geometrical thing like that, especially that size, like, what's up with that?
it's
If you could move your mic a little bit up too.
okay.
Almost eat it, but don't eat it.
It's a thing called a Rossby wave, and so it's the same. The reason you get the hexagon there, if you were to kind of unwrap that and make it just a side to side like a map, you would see up, down, up, down, up, down. In fact, you'd see it's a sine wave. It's a smooth curve. So you do get those on Earth as well. You know the polar vortex that we're so wonderfully familiar with?
I'm the worst person.
Yes, we do.
Yeah, a bit where it just gets cold as fuck, and then all of a sudden it's kind of okay. It's just like you get smashed by all of this Arctic air.
Oh,
And so
okay.
there's a jet stream that flows around that separates the Arctic air from it's not tropical, but whatever normal air is around these latitudes. So when a polar vortex is when you kind of get these waves that they fold in on themselves, and so you get a pocket that forms and smashes the northern latitudes. So on Saturn there's no, and that the reason it's irregular on Earth is because there's mountains everywhere, there's land, and so on
just
Saturn
starts it, yeah.
it's perfectly smooth, and so there's no surface to speak of, and so you have just a fluid that's going round in a circle with no interruptions, and so when those waves form and then you wrap them round into a circle, it ends up looking kind of like a hexagon.
That's funny.
But they didn't, like, they were completely caught off guard, though, right? Like, they didn't know that existed? Or did they have, like, a theory that that's what it was doing?
I guess, I don't know, I guess when they first saw it, it would have been a head scratcher. And then usually with these things, someone's done some math at some point in history, and you go through and, oh, it's that thing that's going on. So you can kind of match up phenomena that you've identified before with, does this fluid's behaving the way that it normally behave, but in a very different environment, I guess.
Okay.
Why it's at one pole and not the other? That's a good question.
That was where I was going next. And then, would it be common to see it on other planets like Saturn? Like, is it possible that maybe like Neptune or Uranus has that?
Possibly.
It's Uranus.
It's Uranus. Anyway.
Oh my God.
That was low hanging
We were
fruit.
doing
we,
so
we
good.
had to do it. We had to.
It had to be
Yes,
grasped.
thank you.
There was
Thank
no
you.
other way.
He's never heard that. He's never heard somebody say Uranus without somebody else blurting out Uranus. So it just had to be me.
It was necessary.
Sorry, just to
necessary.
It's necessary. It's completely necessary.
Oh, man.
I
think
apologize.
it depends on. There are other factors that come into play. So, like the material, the fluids that it's made of, and how far below the cloud tops it turns from gas to liquid. Maybe might have something to do with the magnetic field. Possibly something to do with how fast it's spinning and how much the sun is heating it that causes those waves to form in the first place. So I'm not sure. I think the hexagons are unique to Saturn. I know Jupiter's all weird and blue. Apparently you've seen the pictures from the Juno spacecraft that's orbiting. So whenever you sent something past it before, it's kind of gone like round the side. And if you look at Jupiter through a telescope, it's orange and with all the bands and everything. Mm-hmm. And they found Juno is going in a polar orbit.
Oh, okay.
And so they got much higher resolution images of the poles, and they found that it's blue there, which is, I think, to do with the methane content.
Nice.
Methane and ammonia. So it's to do with the gases that are in those at those specific latitudes.
So Jupiter's blue on the poles, on the top and the bottom?
On the top
Holy
and the bottom, yeah.
So it's not due to the scattering of the sun's light,
No, I guess it is, but it's not. It's
like our
to do-
sunsets, you know.
It's to do with the way that the gases are, to do with which gases are there absorbing and reflecting the light.
Oh.
So, but yeah, Jupiter's weird.
crazy.
Just incredible pictures of it. There's, I think that
I'm
one
gonna have to
pole.
check that one out.
I think there's the storms like vortices, hurricanes, and at one pole it looks like there's a central one, and then there's like 8 around the outside of it, and it's one of these things. So it's a kind of a pattern, but it's a chaotic pattern. So it's ever changing, but there are always this number of storms there. There's maybe one that's forming and one that's falling apart. And at the South Pole, there are less. I think there's 5 around one. So that north-south thing where you get the hexagon at the north with Saturn and the south is just circular, it might be the same sort of thing.
Are those like the smaller versions of the big red spot then? Or
Yep.
but that one's gonna
I'll say little
eventually
tiny, big in the planet.
disappear, right?
The great red spot.
Uh-huh.
Yeah, they think so.
Yeah, I thought they were seeing it like slow down or something.
Oh,
over the
I have
last
seen
few
those
years.
pictures before.
I had not seen
Yeah,
those.
I've
That's
seen those
freaking
before.
cool.
What the fuck happened to Pluto, man?
It's still there.
I know, I understand that, but like,
Is it the whole thing whereby is it a planet? Is it not a planet? It's a planetoid, and that solves the whole problem. Mm-hmm. It's a good word, planetoid.
I'm gonna clip this because
agreed.
I know a lot of people have this question.
Haven't you ever seen like Neil deGrasse Tyson probably has like
Have you ever met him?
the most like iconic explanation.
I used to like them.
You haven't seen that?
You used to like
Dude,
before they
I
demoted
need to,
Pluto.
I need to touch up on my whole astrology part because I am lost, but it's so interesting because you
mean
go back to
astronomy?
Same shit.
It's not.
It's not.
It's
Okay.
really
What'd
not.
he say?
Astrology.
Oh man,
Sorry.
he wants to
I
hit
was
you right
waiting
now.
for him.
He wants to hit you with that coffee.
Okay. No, more serious question. Does it ever bother you that, for example, your job
That somebody calls it
your-
astrology.
Yes.
because
Yes.
your job
Oh, man.
kind of like dictates our future. And like me, my job is to worry about making content so people can see social media.
I don't know how much.
Dude, everybody has their place, man.
Science dictating the future. I feel like it's business that dictates the future.
You think about
Yeah,
it so much.
I agree
like,
with him.
yes.
Where the
It's more
goes
money.
is-
My job compared to your job, I think your job's a lot more important for all of us than I guess mine. And complexity.
No,
I
not
think.
really.
No, I wouldn't
John's
say
going
that.
to enroll in astrology school after this
Yeah.
podcast.
No, because people that not you.
Then you'd be predicting people's futures.
So not you, but like not me, not us, but but content creators are the people that get the word out so that more people are interested in this subject. And so it's like everybody has their place, man.
Yeah.
If
I
no
just
one was telling anyone about it, then no one would know anything about
Yeah.
it. And as an engineer, there's this kind of thing whereby like the blue-white collar
so many
divide
questions,
thing,
yeah.
which is to me is annoying. So if you're a white collar person or black collar, but it's white, on the
Yeah, a little
inside,
bit, yeah.
it's people assume that they're because they have the degrees and because they do the math and because they keep nice, clean, shiny hands and don't get covered in grease, they're somehow better than the people in the shop who are making stuff.
Right.
This is absolutely not the case. Without the people in the shop making the stuff, nothing gets made. You can draw things all day long. So without someone turning the wrenches and knowing how the steel's going to behave when you know when to stop turning the wrench, without those people, like someone can design and build your car. Who's going to fix it when it breaks?
Yeah.
No one's sitting in an
Yeah,
office
everybody has their
So I was just thinking the complexity of his job is just crazy.
Well, see, but there's probably aspects of our job that are complex to him. Probably not.
How hard is it for you to
say.
pick up anything, like, for example, like, just to fix your own vehicle?
It's I try and avoid breaking it in the first place, but I do drive a Ford, so it has a mind of its own.
John is very familiar with fixing broken things.
So I had another question. Are there any things that you like that you were mandated to study that you have never used? Like, for example, the mitochondria being the powerhouse of the cell.
The Pythagorean theorem. Who
Hey,
the
that's
fuck?
pretty important.
Pythagorean, he's probably uses that a lot.
There's a lot of I guess stuff that I did at high school. I went to high school in the UK, so I did Latin, which is utterly useless. It's a dead language, and unless it becomes like, okay, well, it's interesting. I can see where that word came from. It's completely irrelevant.
Isn't that used a lot in like scientific?
I guess if you go into medicine or something like botany or whatever, but then again, you remember what the thing is called and how to pronounce the thing, and that's it. You don't need to know what it means. So understanding, like being able to translate, I couldn't translate things into Latin anymore, but that struck me as the most useless thing I've ever learned. It was Latin. It's a dead language.
Do you know any other languages?
I speak a bit of French. I should speak Spanish.
Hey, let's hear
I
it.
don't because I'm lazy and bad at languages. But
Is there a lot of Hispanics?
He's an
that work
astro nuclear
we have
scientist, and he just said he's lazy. That sounds
That sounds
like not
very
a thing.
with you? I'm
contradictory.
asking a very
Yeah.
important question right now.
I think we have two or three
From the motherland.
on the fellowship at the moment. Last year we had two from ISU
Oh, so
who were my Padawans.
Does Jorge still work there?
where?
Because he used to work, I think, where he works. But he used to work in the administrative part of it, I think.
Oh. So you have your PhD in your career.
I have a PE. I'm not sure if I have a career. But I have a PhD.
So you're a doctor technically.
Yeah.
So we could refer you to doc.
It amuses me whenever people remind me of this.
I love it.
Because
I
you answer
don't
the
know
phone.
many docs in my
We have
life.
like the smartest person and probably the...
Do you
I
ever
don't
use that?
say-
Do you ever use that as a flex when somebody's like being an asshole and you're just like, "Excuse me, it's doctor."
I haven't had a chance to yet,
Oh,
but
man.
that's one of the reasons I got the PhD was just so that if someone was annoying me, I could just...
It's
Yeah, you could correct them. Yeah, it's doctor. Excuse me.
That's crazy.
Yeah.
So I had a... Well, do you have a question?
I have
'Cause
a lot
gonna
of questions, but
kind
you're
of-
good. You're
No,
good. Do what you want.
You go ahead because I think I'm going to take a different direction. Go ahead.
Are you gonna have him ask us
So-
questions?
Yeah, ask us questions.
I do
So
have
how
cutlery questions.
how close do you think we are to using a rocket with the kind of stuff that you're trying to do with like an actual nuclear rocket? And I guess you're talking like as a launch fuel, not as like a in space fuel or both.
As in space, there's no way you would get nuclear rocketry past any form of safety people for launch.
For launch. Okay. So it's mainly a propellant in once you've reached escape velocity or whatever. Once you're in orbit.
Post liftoff.
Okay.
Yep.
Okay.
Yep.
I sounded stupid, huh?
So wasn't
You said it.
I remember hearing, and maybe it's explosions, but
The parasail?
No. It wasn't. I thought there was like a treaty or something that no country was going to use nuclear stuff in space. Is that just explosions? Is that just like
I think
Is that
weapons
war
related,
stuff?
basically, or
Yeah, it's nuclear weapons in space.
Okay.
I can't remember how much they have to. Again, this is law. Like space law is another whole thing. But I don't know if there are modifications to the treaty that are necessary. In fact, no, they can't be because there have been reactors in space. There was one. Again, throughout time, we've done experiments in space with nuclear reactors. There was one on a Russian satellite, Cosmos something, spelled with a K, that re-entered over Canada and spewed radioactive coolant.
There's nobody in
all
Canada
over.
anyway.
It's
so
a
it's
tundra.
Is that why?
How convenient.
Is that why we can't get rid of nuclear waste, like by sending it to just into space?
It's expensive. to
Yeah.
launch stuff.
Is
It's
that
like
more? Okay.
squillions of dollars a pound. That's my figure. I'm sticking with it. Squillions of dollars.
Nice.
It's more expensive to throw it in space than it is to.
Oh, okay.
Dig a
So it's a
hole
money
and
thing, not necessarily
And ethics.
ethics or dangerous or safety thing,
I
or
feel
is that
like
part of it?
Once there's out of sight, out of mind, and once you go beyond the von Karman line, 100 miles up into space, just no one's even thinking about it.
Yeah,
So-
because I mean, what could it possibly?
well, I could re-enter over Canada.
Yeah, exactly. Like you said, what
That's a good
could
point.
possibly go wrong?
Okay, I have 2 questions, and let me go for.
Dude, I have like
I
17
have
questions.
2 questions that I need to get out for
Okay,
sure.
go.
Oh, great.
SpaceX, is that a job that is in your sight that would be like, fuck yeah, I want to work there, or is it a joke? Or maybe not a joke.
Or somewhere in
because that's-
between.
These are extremes.
Yeah.
They're doing the reusable rockets. That's never been done before. It was always considered to be too risky, and people would have told you were crazy before they did it.
Right. There's always that one person.
That said, to cripple my chances of ever working for them, I feel like the Starship is a boondoggle.
Okay.
Can you and now follow up? What is a boondoggle?
Colossal expenditure of
Oh,
money
okay.
for little ultimately practical purpose.
Oh.
Like you can do it other ways, cheaper.
So John's a boondoggle.
No.
Oh, yeah, 100%.
Okay. Anyway.
100%.
Last question.
Sorry.
And maybe this will help you take it to wherever you're trying to take it.
Okay, I think so.
We make knives.
Oh no.
So, knowing what you know, how difficult do you think would be you take a look at our operation machinery and be like, you guys can be this more efficient, or I think
That's
you
a
guys
good
could
question,
figure
John.
out
Jeez.
a few things, and are you
Johnny.
looking for a job?
I feel like it would be extremely difficult because I'm not well versed in the processes. I don't
But
know like
machining wise, with the whole, because there's someone behind a computer telling the machine what to do. So if you understood the machine, I mean, maybe just like anything, you just need to understand the process. But how complex do you think that would be to be able to be like, you guys should just do this and you'll be this more efficient, or you guys could change this and machine wise and stuff like that.
I don't know. Obviously, the company's existed for a long time, and as such, you're familiar with the processes, and you probably, because familiarity with the process is more important than just sort of raw number crunching.
Okay.
So knowing, this is what I was saying about the people in the shop versus the people in the
People in
design
the-
suite. You know, it's once you know the machine. I couldn't manually. I mean, this edge, I guess maybe I could cut because it's like that. But
Yeah.
I couldn't hone a knife to the. You tried sharpening drill bits on a grinder,
Yeah.
and
you
then
have to get the right-
watching somebody who has done that for 20, 30 years. There's no way I can approach that level of
Right.
finesse.
But it's
not-
more muscle memory at that point than
Yeah.
because
It
because
takes
you
time
have the
to-
theory. The theory's easy. Just put it at this angle.
It takes time to develop the
And
muscle
to-
memory,
yeah.
you know, and to know when not to go too far and end up with the bevel on the end rather than the actual. There's manual skill.
Yeah.
is
Yeah.
a very different
But
thing.
I think for you, it would probably be a waste of your talent, like doing that.
I enjoy practical things. I've said I think my thesis had about 4 equations in it. So mostly what that was about was designing. It was engineering, like designing and building a pressure vessel with everything plumbed into it. And so the people at the lab didn't believe it wasn't going to go off like a grenade, despite the fact that it was 3/8 thick aluminium. Which is like, to someone who knows that a domestic water system is 70 psi, it's obvious that that's not going to blow up. But these, again, are very, very highly, like very cerebral, very theoretical people who can't just look at a piece of. You could probably look at a piece of steel and tell me whether or not it's worth making a knife out of,
Oh, okay.
or whether it's junk steel. You know,
Yeah.
it's
Yeah. They
Some
they
of
would.
yes, in some cases yes, in some no. If you're looking at something like if you're looking at a vehicle, you know that the leaf spring will work as a knife because it's a spring steel and it can be hardened. But if you're looking at just a random piece of steel, you're not gonna know if it's hardenable or
Until
what
you
it is
do it.
unless there's unless you know what the alloy is. So it
Then-
depends.
Then once you get into the thing, I'm leaning towards this. What once you've started to actually to apply the
To
machine
manipulate it a little bit, yeah.
you know what the behavior of the metal is like, and so it's that knowing the materials is, I feel it's more important than being able to draw something you can draw something very, very pretty in CAD, and architects have this problem with and structural engineers. So the classic thing is, the traditional thing is that the architect will come down and go, "This is my vision," and the structural engineer will just look at it, squint, scratch his head, look at the architect. You are aware that gravity is a thing, right? And so just the further up you go, the less of that instinctive, just sort of understanding of how materials behave you get. And so as an engineer, I value that sort of skill over the highly technical. I think it's kind of something you either have or you haven't.
Yeah.
You know, it's just knowing how the material is going to behave.
Would it be
That's what
possible?
you can design.
Would it be possible to make a nuclear-powered forge?
Jeez, you put it in and it comes out.
And you die because you got cancer.
No knife.
You would need a lot of plutonium, I think. But yes. Well,
So
plutonium, uranium,
that would be pretty impractical then.
It would. Yeah, I don't know to say impractical. But
I guess it depends on what you need to heat, how large the piece is.
what temperatures you need.
And then you need a wall lead apparently too.
Yeah, other lead glass. You'd have to have remote manipulators and stuff where you have like the
The
thing
robot
and
arms, all
yeah.
that. Yes.
We wouldn't need Ben.
I have a question. So like,
Sorry, Ben.
I have a question, but I need your help asking it.
Okay.
So we'll tag team this somehow.
Sure.
So the question is, we'll explain the context, and then the question is going to be, as somebody that knows a lot of how neutrinos work and all this stuff, how bullshit is what we're about to ask. So we were
on
watching
a scale of 1 to 10.
Yes.
Yeah.
10 being complete,
yeah.
0 being
because
absolute
to
trash.
us, to me and to Craig and I, we watched this video, right? And it sounded like, oh, that's like maybe plausible. But for somebody like you that knows how this stuff works, like where you're like, is this laughable? Is this... So basically, the gist of it is that in Antarctica, there's a neutrino thing that can create earthquakes, and that when they turned it on, created the earthquake in Churchill and New Zealand. I don't know if you've heard. So can you elaborate more?
We're going into aliens.
This is where I need your help.
It's
not necessarily aliens.
We're a good place.
We're gonna go real deep here. So
So help me ask my question.
yes, I think
because
I know
I got
you're-
lost.
Okay. Have you heard of Ethan Greer?
Steven.
Stephen Greer, yes. Yeah.
Not Ethan?
No, Steven.
No,
It's
he's
Stephen?
the
Steven.
Disclosure Project guy.
Yes. Yes.
The-
Okay.
yeah, MD,
So
yeah.
he recently released some kind of press release thing. It was like a 3-hour conference, and he talked, and he had some other people talk that have had experiences that either they had signed NDAs or they had been threatened, like you cannot talk about this, that kind of thing. And it all is, he's bringing it all to the aliens.
Yep. Because it's
so-
always the answer at the end of the day.
Yeah, and to us,
And I'm so interested in it.
and to us, there's like certain stuff they said that sounded like not necessarily plausible, but they sound like legit people. Like they sound like they're being honest, and that they're saying what they're saying. Okay, maybe we don't know enough to say, okay, this is bullshit and this isn't. But this neutrino thing is
Yeah.
like what we were looking at each other like.
Yeah,
this
so
makes no sense to me. But
So one of these guest speakers that he had was this guy that worked for Raytheon, and they sent him down to Antarctica to do something with whatever kind of power station they had or whatever. And I mean, Raytheon is like a weapons manufacturer as well.
Yep.
He said that when he got down there, the way that this thing was built, it had capabilities and it had like a level of power that didn't make sense for what they were doing down there. And as he started looking into it, he said that there was something that was going into the core that had some kind of neutrino thing involved. There was some kind of and the way that it worked is supposedly is powering the station, but what they were actually able to do is create faster than light communications. The thing created some kind of earthquake. There was also some other thing on the complex that supposedly wasn't on or working that was. And he was relating all of this back to Raytheon is doing this to monitor for extraterrestrial activity because they're in the military industrial complex. What they're afraid of is aliens coming to kill us all. And this guy's like, that seems absurd. Why would they do that? But it was this whole thing. So what do you know about aliens?
About aliens.
and how much danger are we for saying this?
Yeah.
As a foreign national, there are things that the federal government knows that I probably never will. But it's, as far as I know, the thing at the South Pole is a neutrino detector.
Yeah. So what is that? What is that?
So when you have, it's back to the physics, sadly.
Yes.
Yeah.
Yes.
When you've got you could start with a neutron, and so protons, neutrons in the nucleus, and then electrons orbiting.
Yep.
So your
99% air.
when you're
Or
empty
99%
space.
empty. Yeah.
When you've got your stray neutron just flying around or in a straight line, and it decays into a proton and an electron, the laws of physics state that you can't just have an electron. You have to have basically the opposite of an electron, but that has no charge. And so that particle that comes off is a neutrino.
That's okay.
It has a spin half and no charge. So it's kind of a tiny, tiny electron with no... So tiny they don't know what the mass of these things is. It may be 0, but they think it probably has a mass. They're small, they're incredibly difficult to detect. And so there's this fast... There's a lot of things that relate to neutrino experiments that I feel like have been mashed together into one thing. I'd have to read the press release to be able to gather the pieces. But at one point there's a neutrino source. If you smash electrons or protons into the right kind of target, then you can get a neutrino beam out of the back of this. And so they were measuring, because they hardly interact with anything, you detect one in a squillion. Is that number again?
Nice.
At the other end. And so for the Gran Sasso Neutrino Laboratory was the thing, and they were generating them somewhere, and they were picking them up somewhere else on the other side of like the mountain range going through the crust of the Earth.
Yeah, that was like in 2012, right?
Yeah, and they were thinking, the way that they detected them, they appeared to be moving
It's a movie.
faster than light. And eventually, physicists want to explain everything in terms of just, this is stuff we already know. And so the idea that that some of the neutrinos might have been moving faster than light was like, this is impossible via the current understanding of physics. And so they maybe, in my mind, there's still, you can put it down to experimental error. This is one way of explaining it. But then perhaps the idea of something moving slightly faster than light isn't a ludicrous idea.
Wasn't that where they said that the only explanation was that there was a...
That
like,
something
they made a mistake.
Yeah, something was wrong with the experiment, whilst refusing to give credence to the idea that maybe the particle was moving.
Because I remember
slightly faster than
Mr.
light.
Neil deGrasse Tyson talking about that.
Yeah.
On that one
So
show.
their
or something.
ultimate conclusion was that it was a mistake, that it was an error.
I think so.
Yeah, it was an experimental error.
yeah.
They traced it to. But
So this guy's thing is he's saying that
And
it wasn't an error, and that they're actively
And they say they
researching
use
this
it
in Antarctica.
They
Yes.
use it as a. I think one of the things they said they were trying to use it as was like almost like a control tower for
Like an air traffic control for
air
ET
traffic
stuff.
Yeah.
the tricky thing, it would be, so if I have an electron, I guess I could communicate with electrons. Just you give them a certain energy or a certain set of energies in a beam, and then you pick them up at the other end. But they're charged, so if you have to do this in a vacuum. In fact, if a tube amplifier for guitars, the electrons are carrying the signal through that, so you can put oscillations on an electron beam easy. Neutrinos are extremely difficult to catch. So it's like it's like you're firing your electron beam through metal, effectively. Just by the time it gets to the other end, the electron beam, there are too few electrons left to really make anything of. With the neutrinos, you have the same number of neutrinos at the other end, but actually picking them up would be extremely difficult, unless you had some kind of super fancy, top secret equipment to do so. So it feels like, a lot of this stuff feels like it would be good sci-fi plots, but also there's always this tiny chance that, maybe the math does make sense, and they say, Einstein, the thing is like, nothing with mass can move faster than light. This is a misquotation. Nothing with mass can move at the speed of light.
So if the neutrino has no mass, then
It could be moving at light speed. Or if it has a tiny, tiny, tiny mass, then it could be moving just below the speed of light, or maybe slightly above it. There's nothing in the laws of physics that actually state that you cannot have a particle that moves faster than light. It's just difficult to get through the light barrier. itself.
Oh, so his thing was more you can't maintain the speed of light. You're either going to be slower or faster.
Yeah.
Okay,
There's math that shows it. If you have a mass, then the faster you go, the heavier you get. And so the math is such that if you plug the speed of light into that equation, you end up with 1/0, which, as every engineer on the Earth knows, is infinite. Mm-hmm. It's mathematicians will hang you for saying that.
They'll say it doesn't. They'll say it's what do they call it in an unnatural number or whatever the mathematicians.
Unnatural, I thought was negatives.
Not unnatural. It's
I think they would say 1/infinity is 1/infinity. You can't simplify it. But
yeah.
It's effectively 0. So we do a lot of rounding,
Nice. Good.
Well, it's good to know.
Good.
I don't know.
This one's like a side question. Like this one doesn't count as a question, like as part of my questionnaire.
Are we counting them?
Is point 99999 exactly 1? Is 0.99 repeating exactly 1?
Oh man.
Oh, point 0.9 recurring
is exactly 1.
Yeah, the argument, mathematicians would have a shit fit, but
there we go. See, Jesus, it depends.
If 1/9 is 0.111111,
yeah,
and then I add 0.111111 to itself 9 times, and I get 0.99999, then that's 9/9, which is 1, I would think.
Right?
But I'm not a mathematician.
So
we need to find a mathematician.
So
exactly, you need a mathematician
respectfully.
Fair enough, Jesus. Next time we have a mathematician
do you know anybody?
ask that same question.
We never thought we'd have him on
I
either.
know, but so eventually we'll get a mathematician on.
Sorry, I'm trying to
Can you open the doors for us when it comes to...
Yeah, can we get a mathematician
We
on?
want to take our podcast to the next level where we're not telling dick jokes and
We're trying to get experts on it.
we're trying to get actual experts on stuff. Like no matter what it is, I don't care what.
So
it
even
is.
if it's that, we're gonna get an expert on that.
And then I had my other real question was, so you've seen all obviously this is like the big thing right now is AI and all the stuff that comes with it.
Yep.
Do you use it? Is there like any way that it can help you guys out, or is this like one of those things where maybe it's too soon right now, or like
I don't know.
Too early.
It's kind of like a next level of automation. So if you have, for ages they've been doing this. I think with airframes for aircraft. So you feed the computer a shape, like a cylinder with a couple of things on either side of it, and you feed it the laws of fluid mechanics. And then you press a button that says optimize, and you leave it through enough iterations and it will go through, and eventually it will give you something that looks like a conventional jet airliner, because that's the most efficient way of configuring the thing and reducing your drag and increasing lift and all the rest of it. So I think it's arguably you can, it's a stupidly technical term, explore the parameter space more effectively. So with the airframe thing, you have to put the initial thing in.
Yeah.
Whereas if you have a generative AI, I guess you feed in the original idea, and then it will take that and it will try different things and a wider spread.
Like the way I see it, for example, now I don't have to learn something that I only needed to be able to understand this thing, but I would have had to spend hours and hours researching, and now I can just get what I need to be able to understand this thing. So it's like I'm able to do a lot more things faster. Because of it.
But you're only getting answers that are already out there. You're not getting something that it's making up and creating.
But just that alone, that it's doing the research for
it's
me.
Googling everything for you.
And giving me what I need.
It's like when we only walked and someone created wrote a first whatever it was in the earth.
But do you use it?
I haven't, no. I have friends who have ChatGPT accounts, and I know that one of them just feeds it bullshit riddles and until he gets kicked off, which is of course going to be like what most people are going to do with it. But
he's just trolling it.
We should have him ask it something.
That's awesome.
And then we should have him ask it something, and then see if the answer is like legit.
Ask it something
or if
like
it's bullshit.
That's the thing with it. So my other friend he's been using it for the purpose that it's touted for. Like if you've got a letter to write and you don't want to read through it again, you feed it into the AI and it will streamline it and make it look a bit better, like round off the corners and so on.
Yeah.
But then my theory with this is that of all the people they came forth and they said, this is going to destroy the world, it's going to ruin industry and so forth. There's an article I remember reading a little while after thinking this, and it is a bullshit generator.
Yeah.
This is going to ruin the finance industry. This is going to ruin
the
sales of snake oil
Yeah.
globally. Are just going to be, no human being is going to be able to bullshit anyone ever again, because it's like human bullshit versus computer generated bullshit.
Yeah.
It's always the computer generated bullshit is going to be more effective.
Yeah.
And so the computers will take their jobs.
And which
is why they're worried, I think.
Stuff that I've noticed. So, like people that trade stocks and stuff.
Mm-hmm.
Now, like, if you have enough people asking the same question, like it's
Mm-hmm.
even if it's wrong with the thing it tells you,
Mm-hmm.
like even if it says buy this, if it tells enough people, it's going to push the market.
It's a self-fulfilling prophecy.
Yeah.
Yeah.
And so
Yeah,
it's
exactly.
going to mess with a lot of professionals that their whole life has been dedicated to trading and to chart reading and all that.
Yeah, which I think I'd need a little list of references, but there was at one point they did look at people on stock market traders and their experienced stock market traders and people who were supposed to have been able to sort of follow their nose and make a bazillion dollars by betting on the right tips, and they compared this with random chance, and it turned out that
Random
the people who
chances
did best were just lucky.
The people who do best are politicians.
No, the people that do best.
It's probably true.
The people
it's
that
100%
do
true. Yeah, there's like 30 something people in the American Congress that are doing much better than the best
Than the index.
like powerhouses. Yeah.
So
maybe because they know how.
yeah. So the
No
thing,
way.
the people that do the best though out of everybody are people that are dead. Because they don't touch their accounts, so they're just growing.
It's just a compound interest
Yeah.
forever.
Oh shit.
Those are the ones that have always done best. So if you like, what's something I could ask it that you would be like, I can see if it's bullshit or not? Because I'm
Yeah,
not going to
let's
use
get
the
into the
internet.
weeds
This
here.
is just going to be like.
Let's get real deep
Real
into your
simple.
stuff.
I'm not even going to use plugins or the web. I'm just.
You're gonna have to tell them how to spell all of these words because none
No,
of
no,
us
no,
are
no.
gonna know.
I'll figure it out. It'll figure it
I've
out.
got to think of a question that I would actually ask an AI at this point. I'm not sure. I can't think of any.
I use
mine
it to
isn't
help me
mine.
reformat my emails.
Yeah, we're bad at right. We're like I got a D- in English.
Damn, that bad?
Yeah, I barely passed.
It's overrated. 90% of people in the US don't speak English.
Yeah, I speak Spanish.
Oh,
It's like, and this is coming from the UK, where it's 95% of people who don't speak English properly. Yeah, I don't know. I can't think. There's one question only a human would know the answer to, and that is why is a mouse when it spins?
Okay, let's see. Why is a mouse when it spins?
So either it knows or it doesn't, and it probably knows because it's on the internet.
Probably. So your question seems a bit ambiguous. This is what it says. Or possibly nonsensical as it stands, as mice do not typically spin in a manner that would warrant special explanation, nor does it clarify the type of why you are seeking. Are you asking why a mouse would spin behaviorally or metaphorically in some context, or are you using the term mouse in another sense like computer mouse? If you would provide some additional context.
I feel like it's bullshitting me. The answer to that question is because the higher you fly, the fewer.
Yeah.
This
Everybody
is well
knows that.
known.
Yes,
Yeah.
that is well known.
Yeah. So
Did you know that?
this no, I'm totally lost.
Yeah,
on
I'm
this.
just
fucking
fucking-
idea.
Is this like a
No,
Astro
I had never
Nuclear
heard of
physicist joke or like?
No, this is a thing that your grandparents ask you.
Oh.
If you remember that this nonsense answer is correct, then you get let off the hook.
Oh.
Otherwise, you
I
have to
don't
go
think-
to
So
the
any
washing.
answer would have been correct, basically.
No, only that specific one.
Only that specific one.
Yeah, and the fact that it didn't know it indicates to me that it's not human.
Yeah,
there's
yeah.
no person behind there in like
No.
pulling the levers and pressing.
So
the buttons.
that's a good
With
thing,
one
right?
question, he just destroyed ChatGPT.
No, he didn't destroy it.
He did. It's
he
fucking garbage.
just proved that it's
I would
not
never
human.
use it again.
So it's not sentient.
It's not trickery.
No.
It is actually.
So it doesn't pass the
machine.
Turing test or Turing or
No,
how do you
let
say
me-
that? Turing? Is it Turing or Turing?
Yeah.
It's great at comparing camera models.
Do you
don't
know
have
what
to
that
go
is,
in
John?
picture. I don't.
You know what I'm talking about, right?
Look, it did answer it.
Oh, the Turing test, yeah.
Yeah.
So it did answer it. So it said, if you're referring to the old British nonsense riddle, why is a mouse, when it spins, the traditional answer is the higher the fewer. It's a humorous exchange meant to confound listeners because neither the question nor the answer make logical sense. If you're asking about specific behavior, then it's another.
I'm fully not going to go out drinking with this this machine. It's no fun.
Yeah.
It's just explaining. It's
Yeah.
it's not. It can't be mansplaining because it's not a man.
No.
It's what is it doing? It's computer splaining at me.
I think it's just finding every possible thing that's on the internet and that it's been fed and
yeah.
and giving it to to somebody that likes to learn stuff. I love it, but
I'm sure there's a million questions you could ask it regarding. It would know simple answers to stuff, then it will just go and find, and it won't just find the what. So if you ask it what is the mass of the electron neutrino, then it will give you a whole list of like, well, maybe it's this, or maybe it's that, or maybe it's not. These experiments say this, these experiments say that. There are these bounds on it.
But it's going to hedge its bet, basically.
But it's not smart enough yet to say this is this is and be right.
So are we doing AI a disservice by calling this AI? Is it not AI?
It's just Google Plus.
It's not the AI that people think it is.
Yeah.
Because that everywhere I've heard, they say that we're still like 30, 40 years out from that type of AI. This is more like just language learning. So this is just language.
I guess it's creativity. Like the ability to, you can get it to draw pictures and all that kind of stuff, but then I feel like there's something, like creativity, inspiration. That's a thing that's unique to, I don't think that's the thing that a computer is ever really going to.
It's just copying.
Yeah.
It's just copying. Whatever.
It still requires your input. And your input is the inspiration.
Yeah.
Okay.
So I don't think it's ever gonna. This is me. I don't think it's ever gonna create something that nobody's ever seen before, because it's always taking something from somebody. Because where a human might create something that nobody's ever seen before.
In a moment of inspiration.
Yeah.
I feel like it's impossible for it to be inspired because there's that lack of that. I don't know.
And a lot of people see it as a lot of people see it as they don't see it as a tool. Like they don't say this has its place as well. They're like, no, I'm not touching that shit.
Yeah.
But I think a lot of people that do see it as a tool and learn how to use it like you would the internet, like you would Google.
Yeah.
Those people will be more likely to keep whatever job they have, or at least be able to adapt to, because whether you like it or not, like it's like the internet. There were a lot of people back when the internet was first a thing that said this is a fad, this will go away.
I'll never send an email.
I'll never send an email, and now or cell phones. Like for example,
TV was the same.
Yeah, I know a lot of people that said I'll never own a cell phone, and now they don't own house phones. And so I think this is going the same way, where people are just going to use it because if you don't, you're going to fall behind.
But it's not like a crazy thing. Like now, instead of like,
to me, it is a crazy.
It's crazy.
Thing.
Oh, it's
like
crazy.
It's like now you, instead of having a play or you're going to a play to watch people act something, now you can see it on the TV. It's not that drastic of a.
This
change.
is more drastic to me.
Why? If it's just like, it's literally just taking answers from what we already know. What's the difference from putting in Google and, like, for example, what we use?
The difference is that you personally could send thousands of emails a day and never actually write one.
Right, but it says like it takes one step out of the thing. It's not like
it's taking a lot of steps.
It's not like something that's just reading my mind and then just types everything up for me. You know what I mean? That would be crazy.
Yeah, I guess. So it's an extension of
something that's already there.
Yeah, existing technology. Rather than an entirely new.
Do you think it'll ever be actual AI, like what people would consider to be real sentient? Like,
I don't know. It's tricky because ultimately we have no idea what consciousness actually is. We don't know when it arises or how it arises. I mean, we're at the point now where it's difficult to define a living thing. So is a virus a living thing? We don't know. You apply all of these criteria for a living thing to like a bacterium or whatever, and you go, well, a bacterium will exist like a chloroplast in a plant is similar to a blue-green alga. And so the blue-green algae, the mat of algae, is a whole bunch of single cells, and it will exist in its environment, and it will do all the things that life is expected to do, whereas a virus requires the host to live in, but it still has the ability to self-replicate.
So it's more it's more, at the end of the day, it's whatever definition of life you give, like whatever the consensus is, this is the definition.
Yeah, as to what consciousness actually is. So I guess, yeah, if there's something fundamental that defines consciousness, then I don't know if it will ever be possible to build a computer to do it. But if it's something less intrinsic, then I guess the prevailing view of the materialists is that it's to do with the complexity of the human brain. So sentience at the human level arises because there are like a squillion neurons all interconnected and firing in different ways. And so the idea being, if you connect enough transistors up in the same way, that you eventually will have something conscious.
Is this kind of what they're trying to do with like quantum computing?
I guess,
or supposedly is going to be possible just because of the like power that a quantum computer would have?
This is I've read theories that state that the brain might be a quantum computer. So there may be something that's going on, I guess, behind the scenes that gives rise to consciousness. That is, so all potential states of a system exist until you do an experiment on the system and it collapses the wave function, and you end up with one thing that's definitely measured. But they figured there's all kinds of
Schrodinger's cat.
Yeah.
Yes.
The quantum weirdness is such that there are experiments that have been done where after the fact they have changed things, and then they've looked at the results of the experiment, and the results of the experiment seem to reflect the fact that the change was implemented despite the fact that it wasn't changed until after they'd taken the results. And then
that's fucking weird.
Yeah, retrocausality is a thing. So that's what it's known as.
Is that the Mandela effect?
Oh, that might be
a separate thing. Is that not a thing?
That's more the
many worlds, and if consciousness is such that it can, if it experiences a certain reality and all potential realities exist, then why would a conscious thing not be able to hop from one reality to the next?
Oh man,
and back again.
See, that's a theory I've always had. That, like, for example, like if I do something and I die. Like, to me, I didn't die. I'll just switch to another consciousness somewhere else. But to you guys, I did die.
Yeah.
Like, seeing it from your point of view, I did die, and then he's gone, but I'm still alive because, like, I just jumped to another consciousness, and then I'm still
experiencing another reality in which you didn't die.
Yeah.
That's... Yeah, I know, this is all crazy, trippy shit. You ask the AI these questions, and if all it can do is regurgitate what people have
already said.
Google, it's the original idea. That's if I feel like if it comes up with a truly original idea, then you would be able to say that it's conscious. If it decides to do something counterintuitive, generally with humans, if it decides to do something counterintuitive and stupid just because it's fun, then that would be, this is, I think, one thing that defines us as human beings.
Now we're talking.
Yeah.
Like, we're going to do this. Why? It's a bad idea. I know I've calculated this. I'm going to do it anyway.
I think there's a lot of rules that the company, like, limits it. It's because they don't let it just do whatever it wants.
Yeah, they've had trouble in the past, haven't they, with other machines when
they started
Was it
making
Facebook's machines that were making their own language as they were talking to each other?
I can't remember,
or
but
was it
there was
Google's?
one I think in
it was
Japan
Facebook.
where they started creating their own language, and they shut them down because they were talking to each other in a language that nobody understood.
Yeah,
because it was more efficient or whatever, and they just
Maybe.
were like, "This is not good."
So, well, anyway, changing subjects. So, like, for example, if I knew as much as you do and stuff, and I were to go on a podcast, I'd want them to ask me, like, for example, if my area of expertise is this, I'd want them to ask me this question so I could answer. Is there a question that you would love to get asked? And can you ask it to yourself and then answer it?
Yes.
I don't know. I'm generally, being a comparatively lazy human being, I'm happy to live a life that's free of too many questions.
Stop asking questions.
Yeah, I don't know. No, is there an answer? Is there a thing I'd love to explain to people? I don't know. There's a particular area of math which is very abstract and but also incredibly simple and connects to this idea of consciousness and all the rest of it. which I don't think gets given enough philosophical credence. Maybe.
Is it binary?
No, it's a thing called so.
No,
Many people, I could
you
back
can't
of
say
an
that
envelope.
anymore.
Actually, this is
You can.
this is a thing I like to do on the back of an envelope. So if you've got, I've got these things here. I'm going to borrow.
Yes,
borrow
shot
two of
glasses,
these.
do
Yes.
it.
So if I connect these things together
This makes me so happy.
like this, it's I can do. There's an equation that defines that circle, and one that defines that circle. So I can do algebra, and I can tell you the coordinates of that point where they meet.
Like an XY thing.
Yeah, yeah.
Okay.
So, and if I make them overlap, then the same thing. I can tell you the points at which they overlap if I'm taking a section.
Yeah.
If the glasses are here, intuitively they're not connected. However, I can still apply the math to it, and I find out that they are still connected.
Wait,
believe
what?
it or not.
Okay.
So
I'm intrigued.
the reason for this is that you take the square root somewhere in the algebra to find the point, and if the separation is greater than the sums of the radii, you're taking the square root of a negative number, which is
Impossible.
known as an imaginary number in the math. So they are still connected. The coordinate point at which, like the distance between them, there's a halfway point here. But rather than a physical point that I can measure, they're connected in hidden dimensions. And so you can expand upon that, and philosophically, everything is interconnected. Well, you can show this on the back of an envelope if you use the right kind of numbers.
Wow.
And you can expand that, not endlessly, because the more you expand it, the more the math starts to fall apart. So you start. So there's this imaginary number, the imaginary y coordinate. If you're doing it in 2 dimensions, it's easy to show. You just stick a pin through the bit of paper, and now your x coordinate is halfway, but then your y coordinate is not on the paper anymore. It's no longer in our reality. It's no longer something that's visible. We use those kinds of numbers quite a lot in engineering for resonance frequencies and stuff. Complex numbers, they come in quite handy. But you can expand it further. So you have this idea of one hidden dimension that defines the point, the y coordinate of where these 2 circles are connected. You then do some algebra, and you can have 3 imaginary dimensions. Or then you take it one step further, and it goes to 7 imaginary dimensions. And this is the point at which your brain starts melting, because you have to imagine 7 things that are all at right angles to each other.
Which sounds impossible.
Yeah, the gerbil running our brain just fell off the
I
wheel.
should have probably paid attention to Mr. Baldwin in calculus.
The gerbil will fall off the wheel. There's no other way. It's mind-boggling. But the fact that it's useful in engineering to use these kinds of for rotations and stuff. It's with the 3 imaginaries and 1 real. It's called a quaternion, and this is how in a computer you calculate rotations. So if you rotate 60 degrees that way and then 90 degrees that way, or 90 degrees that way and then 60 degrees that way, you end up with different positions. So they don't commute.
Even though they look like...
Even though it sounds like
they should be the
work.
same.
Yeah, you end up with... So it depends on which order you do the operations in. So that's the first thing you lose, is the ability to just do 2 operations and have the same result.
What?
And then it starts to depend on where you put the parentheses in your equation as to whether you end up in one state or another. And then you go one step further and you start getting things whereby you can divide by 0 and it's not infinite. So it's... Yeah, I guess no one has ever asked me about hypercomplex numbers. So I guess that might be the thing. Like if someone came down and sat to me, what is a hypercomplex number, and can you explain them to me? I'd be happy to do that on the back of an envelope. But it's
We should have them explain the whole process.
So does this?
That'd be fucking awesome.
Yeah. Is this where like an engineer and a mathematician start to diverge with dimensions? Because don't they disagree on how many dimensions there are possible?
Yeah, I think it's mathematician and engineer. Philosophically, it's fascinating, and as an engineer, we do use some of these numbers. Physicists are when it starts to get tricky.
They're the ones that say that's 12. Is it 12 or?
Or is it 10 or
I thought they were at 12.
10 or 26, I think. Was
Yeah, it's weird. It's like
string
weird
theory.
numbers, and they disagree on how and why.
But they can never prove it.
Yeah.
The theories that
Yeah.
require these,
So,
it's just
yeah.
the energies are too high, we can never see them, so it's all academic. But a mathematician and the engineer at this point will be agreeing and having an interesting conversation over the beer, whereas the physicist will just be outside
Eating
just
lead.
furious. The fact that you're not doing the math that I like to do. And so I have actually asked physicists this: does an imaginary number have any real physical significance? It's a trick question because you get oscillation frequencies and so forth. You do get them out of the math for engineering, and they always just say no. They're just mathematical convenience. And then you can't say to a mathematician like, well, it's just a language, it's convenience, it doesn't describe anything, because then they get all upset like, what? And you can't tell an engineer like, well, you're lucky that you found a language that explains that. It's like, well, this is the only language that explains this, and thus it has to have. So yeah, the physicist at that point gets left out of the conversation, left out in the cold.
Dude, I should have this thing create an engineer, physicist, and a mathematician walked into a bar joke,
Yes.
Yes,
and see if it makes any sense, and we'll maybe end with that.
that's
I'm not even going to ask him. He has
Ask another
questions for
que- ask-
us.
ask-
what
because
did you
another
call
question.
it again? A hyper complex number?
Hyper complex number.
God damn it! No,
if I run into another engineer, I'm stops talking to me.
now I'm gonna go down the rabbit.
Do you ever
hole.
have?
I'm gonna start
do
going
you
down
ever
the
have,
rabbit
like,
hole and not
questions?
understand
Or, like,
shit, and then I'm gonna
Maybe
give up.
what we do.
That's what's gonna happen.
We need to bring him back.
Yeah.
Because I mean, it's different because I do video, he does graphics, photo, and he
Does the
does the managing.
But I also do. But I also.
he also does.
I can
all
also
the-
do. I can also do like CAD drawings and stuff
Yeah.
like that.
So yeah,
and
he's
I
more
was going to
advanced.
say you're just the media people for the thing, or are you?
we're a mix
he's
of things.
yeah, I'm just yeah.
He's also a concrete expert.
I have a PhD in concrete,
Yes.
so I'm also a doctor.
You don't have a PhD.
He's definitely not.
Oh,
a
and he's
doctor.
also he also worked as a tax.
I'm a wannabe accountant.
He worked as an accountant and got a bunch of people audited.
He's full of shit.
John is a self-proclaimed woodmaster and chess master.
Plumber.
Neither of
not
those things are a
electrician.
thing.
What are you like
He's-
really good at chess?
not
He's
an
probably really
electrician,
good at
yeah.
chess. Huh?
He's a truck driver because
My
his
dad's a
dad
truck
is a
driver.
truck driver. So he's
it
got a
genetic?
lot of, I guess.
But I'm also the only one qualified out of us three to back up a trailer. So
But he's not actually qualified. He just knows how to do it. There's no
did you not just
qualification
hear the
somewhere.
last hour and a half what he said that the guy turning the wrench is as valuable?
I'm not saying that you don't know how to back up a trailer. I'm saying you do, but I'm saying
you're
that
not
you are
you're not claiming me.
You don't
as,
have
like, with
a certificate,
okay.
that says I'm a backer upper expert.
Okay.
You should
Okay.
You should make one.
I am going to print one off now
You
because I don't
should.
think there's
You
one
should.
out there
No,
now.
enter some. There's bound to be a competition like world
Back
There's
up
championship.
a
got to be.
trailer.
Yeah, there's got to be.
Backing.
We started.
You have to be the best at something. I would
No.
like to know what the best
No.
what that thing is, because everybody has to be like the best.
No.
Something.
I don't think I qualify for the best of in any of the categories.
You don't think so?
No, because then there's someone that does it full time all the time, has done it for so many years that could be possibly the best. But then you start thinking about where's the peak of the best. If I make these screws my whole life, at what age was I the best? Because then I'm young, I'm getting used to it, I'm good, and then I start
somebody
becoming
improves
old.
it somehow.
I got
Yeah.
one.
Oh, great.
But you have like if you have
it's
to tell
not-
us if it makes sense, if it doesn't make sense. Well, I guess we'll gauge whether he laughs or not. Okay,
Yes.
here we go. I suck at reading
Can
too. So.
AI make him laugh?
An engineer, a mathematician, and a physicist walk into a bar. The bartender looks up and says, "What is this? Some kind of joke?" Ignoring the quip, they all take a seat at the counter. The physicist orders a whiskey on the rocks, commenting on the fascinating interplay of temperature, fluid dynamics, and entropy in the melting ice. The mathematician, with a smirk, orders a zero-proof cocktail, explaining that he's interested in the
In the combinatorial,
complexity of mixed drinks, even without alcohol. Lastly, the engineer orders a beer straight from the tap. No need to overcomplicate it, he says. A well-engineered process delivers the right product every time. As the night progresses, they debate the nuances of their respective disciplines, their conversation flowing as smoothly as their drinks, painting a vibrant
tableau,
of science, and
camaraderie.
they each offer unique insights into the simplest situations, providing once again that reality is all complexity is simple. This joke sucked.
Yeah.
And
Yeah, I've lost this guy.
Are we still in
I'm
the
ordering
bar?
another drink now. Like, I've gone outside for a cigarette at this point.
you were right.
Yep.
Yeah, this is
I don't even
terrible.
have any
We need
beer
to have
left.
a part 2, man. There's so much
Yeah.
shit we didn't talk about.
Yeah.
That's fine. You're going to be here a couple months, right? Ish.
Yep.
Nice.
I do
He
have-
moves
yeah.
his trailer.
He's like, fuck these guys.
He's like, not anymore.
You know
I
what?
was, but not anymore.
Yeah, I moved across the
He's like, I want 20 holds.
parked in that hole over there.
It's up to Rigby.
Oh man,
We have a shop. in
that would
Rigby,
be
too.
pretty harsh. Because I'm going to learn about hypercomplex numbers for at least a few minutes.
Yeah. You know, next time you come back, we'll have Craig here explain that number, and then you correct them. How's
I
that?
can try. It's a thing. I'm mostly it's wrenches and occasional math, but yeah, it's recreationally interested in this, just philosophically.
Recreational?
Just philosophy.
fun?
The pondering
You've never gotten into philosophy like at all? Of any
Philosophy's
kind?
cool, man, but
Bro, for my fun is Farm Simulator. I'm
Yeah,
interested
okay.
on
I should not have even asked that question. I knew the answer.
I'm sorry.
is there a
The
question you
age
had
of-
for any of us?
Do you play Farm Simulator?
I was driving around today and just
He does simulations for work. I don't
at
think
the
he's
age of
gonna play.
5, all I wanted to do was drive a tractor, and there is a part of me that just wants to drive a tractor.
Leo owns a tractor.
Around
We have a
the field.
tractor.
We
here.
might be able to make that happen.
What if you made like a nuclear battery for a tractor and drove it around with that? How long
And
would it
it
last?
never-
Nuclear tractor.
Yeah, how long would that battery last theoretically?
Depends on the size of the battery and the half-life, and how much excess power you need.
Farm Simulator is a lot cheaper, man.
I don't think I would buy.
yeah, less,
We're talking like a lot of miles though.
I don't know if people out there would buy food that was harvested by a tractor that runs on nuclear, though.
You never know.
That's
People
fine.
are.
It's
won't
fine.
get-
It'll be
skittish.
protected.
People don't get vaccines.
You don't
It'll
gotta
be-
tell people.
it'll be
Anyway,
So yeah. So before
Alright.
we end this, we have something for you.
Oh,
Every guest on our podcast
probably got thrown in the garbage. but
gets
that's fine.
a challenge coin. I don't know if that's a thing in Australia or not.
a challenge. What does the challenge
UK.
involve? Is this a...
Okay, so it came. Challenge coins. My understanding is that they actually came about as a military thing, and what it was is you would get a coin for different units you were in or different things you had done, and when they would go drink, whoever had the least important challenge coin would buy the round. Would buy the first round, and so they would all have everyone
Don't
would
pull it
have.
out because you're gonna get stuck with the
Ever pull
bill.
that one out, yeah.
And so, but nowadays, a lot of companies in the U.S. That's why I say I don't know if it's a thing in Australia or not. But a lot of companies in the U.S. that are involved in some way with military stuff will make challenge coins as like a commemorative thing or as like a for important events, things like that. So
Yeah,
You pull that out there, you're like, what the fuck is
So
this?
the only way to get the coin is to be on the podcast.
We were about to arm the
Yeah, you
army
can't
of-
buy it. You can't. I mean, you could probably sell it. I
We
guess.
do have the biggest podcast in Yukon.
That's true.
barely.
Doubtless. Until Jake, the chief of police, starts one. And then-
Oh.
Well,
No,
fuck.
we'll
Or-
battle. We'll battle with him.
Or
We
you
will-
start one.
Ours will be way better.
Leo is running for mayor of Yukon.
Yeah.
If you start one,
we have your
we're
vote?
screwed.
Yes.
Nice.
Thank you.
Yes.
I don't know if there's competition.
I don't think he
Yeah,
can
we'll
vote. Can you vote?
He can vote.
Oh, yeah.
We're gonna figure it out. He'll
I don't know
vote.
if I can vote.
We'll find a way.
I'll get someone else to cast.
We'll get
two.
you a ballot.
That's
Don't you
legal,
worry
right?
about that.
That's illegal.
We're
Is
gonna be
it?
running the joint.
Even in
so.
Yukon.
If you get somebody to vote for you, yeah, that's pretty illegal.
Don't
J-
we just
So?
make our own rules here? Isn't that the thing?
Yeah.
We also
Fewer
host the
than
biggest
do what we
fireworks
want. It's
show
free.
in
Leo
in
basically
Yukon.
owns Yukon, so yeah.
Yes, it's in good hands. I feel.
Thank you.
More head per capita for sure.
More what now?
I don't know. Okay, thank you for joining us.
Yeah, dude, we almost made it through a whole podcast where we actually talked about smart stuff and
And then John just
ruined
Ruined
it.
it.
But now
I'm sorry.
my brain's drained. I have to go get my gerbil back on the wheel.
I'll
Yes.
just start my-
But anyway,
my-
can you push that top?
Thank you for
keep-
being on the show.
On the thing, can you push the green button over there on the thing?
Wait, the green
There's
thing?
The
Yeah,
green button.
no,
The
push-
green button.
I'm colorblind, man.
That's the wrong button, sir.
No, that's the right one. Push the one.
Push
right
the one
above
right below
button.
that one. Right below the green one.
No, above that one.
Right below the green
Above
one.
the green one.
I had no idea how
Nope, the other one. Push that button again.
The top
Turn it
right
back
one.
off. No, turn it back off.
Push the left top one. Top
The red one there, and then push the
next
one to the right of it.
Yeah.
There we
There you
go.
go. Okay.
Thanks, everyone.
Thank you.
Thank you for having me.